In this video, I first of all like to go through the tools I'm going to use to test the wiring and then show you some of the things I've found while testing the wiring. For testing the circuits, I'm using a couple of pieces of equipment. The first one is a power supply. This is a DC power supply. I can dial in the voltage. I can see how much current and how much power is being used. This is great if you're unsure whether you've got a short or not. You can plug it in, you can dial up the voltage, and you can see how the current's going up. Once the current gets above, say, an ampere with everything off, you know there's probably a short circuit in there, so you can go and sleuth that. Otherwise, no, if you hook it straight up to a car battery can deliver a lot of current, and you can burn through wires very quickly and even cause fires. So this is something that is great in the initial phase of sleuthing out whether your harness is fine. The multimeter, I've had this one for over 35 years, is awesome. It's an all-purpose debugging tool. You can test for continuity, you can test whether there's what sort of voltage is there, and also test to see if there's resistance, how much resistance is there. That's great. However, that's sort of been superseded by this new widget that I've got. It's a power probe. So you hook it up to a car battery or to a power supply, and by putting in the probe at the top, it will tell you whether that where you're plugging it in, whether that's at 12 volts or 0 volts or somewhere in between. It also tests for continuity. There's an extra Y here that allows you to test to see whether there's any continuity there. So you can test for ohms, you can test for whether there's a signal there, and there's even an AC signal for those sensors that produce pulse width modulated values. You can see whether they are working. So I'm expecting that I'll use this more than I will use the multimeter, but that's great. If you have got some current problem, like it's drawing too much power from somewhere, this is something that's very useful. It's an AC/DC clamp meter, so it measures current. And this is great for finding out what circuit is consuming all the power. You can put the wire by wire within those jaws, and it'll tell you how much current is actually flowing through there. This one, I don't know whether I need it. I've never used it so far, but this is a mini digital oscilloscope. Again, you can actually see what signals are being produced, especially if they're, again, from sensors and they're pulse width modulated signals. You can see it on here. And finally, this is specific to the Busa. This is a Hilltech Suzuki ODB SO1 kit. So this plugs into the diagnostic port of the wiring harness, and there's some software that you download from their website, and it will give you it will talk to the ECM, and it will give you everything that the ECM sees. So you can see throttle position, all the sensor values, and it will tell you if it's unhappy. Now, the only other way of doing that would be to have a dash that you plug in and then use the codes on the dash to work out what's going wrong. This seemed to me, I don't have a dash, I just bought the engine and the loom separate. So I'm going to use this to check to see whether, before I actually turn the engine over, to see whether everything is happy, whether there are any codes or what have you. So they're the things I'm planning to use. I've got a little bit of wiring to do just to plug in some connectors for the lights and things before I can start testing. And before I did that, I wanted to show you test what I've done and the equipment I'm using. Okay, the first test is just to see whether we've got a short across the power leads. So I've got the multimeter across the two power supplies, and we can see we've got 1.8 mega ohms. This is with everything switched off. And I've got the instruments also over here. I've got them unplugged as well. So things are looking okay. Next is to put some power onto the circuits and then start buzzing things out, testing the switches to make sure that we've got continuity going where we expect it, and then going through circuit by circuit. Okay, so now I've got the power supply connected up. You can see I've got it dialed into 12 volts and it's drawing 0.003 amps. So essentially very, very little. Not surprising because there's very little actually connected up. But what I'm going to do now is start buzzing out the circuits. The first error I found was in the power connector going to the dash. I had reversed the switch 12 volts with the illumination power. What that meant was that rather than getting switch 12 volts going to the wiper here, I wasn't getting anything, so hence the wiper circuit wasn't working. So that's why we buzz things out, and that's why we check each circuit. So I just repinned this and we'll try again. Okay, I've buzzed out all the circuits apart from just swapping the illumination and the switch supply around on the connector to the dash. Everything seems to be fine. I've now plugged in the ECM. I found another problem. This is the horn loom here, and what you see on the circuit diagram, and what I didn't realize at the time, is that the horn has a constant 12 volt going to it, and the switch actually switches the other side of the horn to ground. Now my horn, which is this one here, I took off my Corolla, and it just has a single signal here, and the body itself is grounded, which meant that the way that it was wired wouldn't work. So what I'm doing now is that I'm rewiring the horn switch to go outside of the loom. So basically I've got the switch here, and the switch switches the relay to 12 volts, and then I'll put 12 volts out to the horn itself. So that's the next thing I'm doing.